Okay, welcome. So this is going to be the Excel sheet that you're going to download. It's called the M&M Excel sheet. And what I want you guys to do is to get a giant bowl full of M&Ms. I want you to count out at least 100 of M&Ms and put them into a bowl. Well, imagine my coffee mug is full of M&Ms. It's not because I have a peanut allergy, so I'm actually allergic to M&Ms, but you don't have to eat them. So you're going to get some M&Ms, you're going to put them into your bowl. Then for the first 15 times you do this experiment, you're going to count out 5 M&Ms. 1, 2, 3, 4, 5. You're going to look at them and you're going to write down how many of each color you have. How many blue, brown, green, orange, red, yellow. Please don't get any of the weird kind of M&Ms that are like, 4th of July colors or anything like that. You want the classics, okay? Then you're going to take, after you've counted your 5 M&Ms, you're going to put them back into your bowl, and you're going to do it again. And you're going to do that 15 times. And the Excel sheet is set up to sum up those, so give you the total, make sure it's 5, and then calculate percent blue, percent brown, percent green, percent orange, percent red, percent yellow. Blah. And then it will calculate a mean and a standard deviation for percent green. And the reason we're doing this is because the Mars company claims that 16% of M&Ms are green. And we want to see, are they correct? Is that true? And the way we can do that is using a t-test. So I have it set up here to do the t-statistic. Keep in mind, our t-statistic, again, oh, I scrolled way too fast. Here, right, we're looking for the mean of one minus the mean of the other, divided by that standard deviation with the sample size. So I have that set up, okay? Once you do it, the mean will also populate here, and we'll start to make a graph for you. All of this is set up, so all you need to do is put in the numbers here. Don't mess with anything else in the Excel sheet, because you'll mess it up. Okay, once you do that 15 times, we're then going to look at the effect of sample size. So what happens is our tests get more accurate if rather than taking 5 M&Ms at a time, we take 25 M&Ms. So in 16 through 21, you're going to do 1, 2, 3, but you're going to go all the way up to 25 and then count them, put your counts, calculate your percent. Now, in the last test, I want you to do the best of both worlds. So not only will you count it out 25 times, but you're also going to do lots and lots of replicates, right? So each M&M that you count, 5 or 25, that's considered your sample size. You have a sample size of 5, you have a sample size of 25. And the number of times you do that experiment, that's considered a replicate. So in the first iteration, you do 15 replicates. Then for this one, you're going to do 6 replicates. And then you're going to do, I think, again, 15 replicates, okay? And all of that will be calculated. And so what I want you to see is how close you get to that 16% based on sample size and replicates. What is the impact of sample size and replicates? Then we're going to compare two unknowns. You're going to copy your percent green from right here, and you're going to right here. For the second time, I want you to do this for not just the 5s that you did, but all of them, the 25s and the 25s. You're going to copy those 3 sets of percent greens into one column, put it right here. We're going to see how different it is from 16. The t-test is already set up for you, okay? And then finally, we're going to compare the two means. So I want you to put the ones from your 5 counts here and the percent green from your 25 counts and see, are those different from each other, okay? That is your M&M experiment. You have a Word document with some questions to consider that I also want you to submit. So you'll submit your filled in Excel sheet and your Word document, and then you can eat all the M&Ms you want. Best of luck.